So this is data visualization using a package called Seaborn, right? So I think you all know that this matplotlib, that we use to make charts in Python. So what's the difference between matplotlib and Seaborn? Right? Matplotlib is like a very robust, a very customizable, library, but it requires a lot of code to write a visualization compared to Seaborn, right? Seaborn is more high level. With lower line of code, you can write and make a visualization, right? It is slightly bit, less customizable compared to Matplotlib, but it's definitely easier to work with, all right? And it has lots of different varieties of visualization you can build. It lets you build subplots inside plots. So yeah, I was saying Seaborn is a bit high level compared to Matplotlib, right? It also lets you build subplots inside a single plot so that you can, make some good analysis using those charts that you can make in such type of visualizations. And Seaborn also works well with pandas, whereas Matplotlib works well with both NumPy and pandas, right? Yeah, that's pretty much. So I would say this is more so anybody who wants a larger amount of control and customization on the visualization should go with Matplotlib, or anybody who wants more functional and organized viz, right, that takes care of a lot of things by itself, but just the type of viz and columns you want to give in and make some really nice plots, you should go with Seaborn, right? That is the difference, right? Right, cool. So I'm just going to show you some introduction to Seaborn on this section. So I'll make a few plots, right, different types of plots, and I'll just explain the different arguments that go into those functions, right? So here I'm just importing all that is required, pandas, matplotlib, Seaborn, right? And this is a function called median from NumPy. Right. So let me run this. So Seaborn also comes with built-in data sets, right? You can load them using this function called load dataset, right? And it loads it into a data frame, right? I have named it df. So this is a dataset called tips. Okay, let's see what it contains. It contains 244 rows, right, and 7 columns, and these are the 7 columns, and all of them are non-null, 244 non-null everyone. So, and these are different types of columns. So it has, I'll show you the, okay, this is how it looks. So each and every row is one group who sat at a table on that restaurant. Okay, so how much was the bill amount? How much is the tip they gave? What is, sorry, not one group, it's one person who ate at the restaurant. So how much is the bill amount? How much is the tip? What's their sex? Smoker or not? When did they eat? What time did they eat? And what is the group size on that table? Right, that's the database. Right, now let me show you first, just easily how to build a scatter plot. I want to see, visualize the tip versus total bill amount, right? So you call in SNS. So basically I've imported Seaborn as SNS, right? So this is like a short form for it. So I'm calling SNS.scatterplot, right? I'm going to tell the data is stored in df, right? In X you just plot the total bill column, which is this column. In Y you plot the tip column, which is this column. Right? So it gives a X and a Y. It gives the names by itself, right? It also plots the legend once you tell what color to use. I want to differentiate the points by using this sex column, right? So it gave us 2 different colors, right? So that's it. This one line is able to create this decent looking plot, right? Now I'll show you how to create some changes on it, right? So I just want to change the color for these 2, gender, and so what I've done is I've created a dictionary, right? This is called a dictionary. It basically, it has this curly braces around it, right? And it's also key value pairs, but here I've only given the values, right? So this is one color and this is one color I wanted to use. So basically I create a dictionary, I've given the hex codes, and I use an argument called palette, right, and call that dictionary here. Palette equal to color dict, right? You see the color changed, right? Right. I think this one should come. Maybe, yeah, that's fine. All right, yeah, the color changed like I wanted it to, right? There's also another way to change this ordering, right? So that you can use hue order, right? And then you can give a list of what that order should be and just call that list here. Okay, here the list is going to be on this square brackets, right? So each of it is a data type. So dictionary is a data type, list is a data type, right? And you have lots of things that you can do with those specific data types and why they should be used, but here it doesn't matter, right? But this should be in a dict, the color palette, and this should be in a list, right? So now I've changed it to female and male, the order, right? So I'm going to run this again. So you see now the order changed, right? But I didn't want the color to get swapped, right? The color is in the same order, right? But just the legend order alone changed, and hence now the female points are marked, in blue, and the male points are marked in pink. I didn't want that, right? I wanted both the color and order to change. So the way to do it is this: you have to map the inside the dictionary. Now you use the key and the value pairs, right? You map the label with the color, right? And then you call it. Right? If you change it now, it will change, right? So one more thing I've added here is the size. Size is another column here. If you remember, that's the table size, the group size, right? So I've added it to size, and it'll change the size of the dot, right? And to make it transparent, I've added alpha, right? Now this legend looks a bit longer, right? You want to get rid of this, right? You can do that. This is legend.remove, right? You run it with that, it'll get rid of the legend. And there's also customizations for removing parts of the legends as well, right? You can do that as well, but for now I'll not show it, right? So if you want the size to be removed but the sex to stay, you can do that as well, right? Yeah, so that's the basic plot, the scatter plot with some visualization, like some customizations, the color, the size, right, and the palette. Okay. Everybody good up until now? Any questions? Okay, I'll proceed forward, right? I'm going to a line plot, right? So this is, I'm gonna show how much is the tip that they received on every day of the week, right? So how a line plot is used is it basically gives 1 point for every X label, right? So if there are multiple observations for that X label, then it's going to aggregate those observations into a single point, right? That's the line plot. Okay, so it's going to give an aggregated tip for 1 day, for Monday, Tuesday, Wednesday, like that, right? So here it is, and the default aggregation it uses is mean, right? So you have these days and you have the mean, and it also by default gives you a confidence interval around it for the mean, right? And by default it's set to 95% confidence interval. So all these are the advantages of using a Seaborn package, right? In matplotlib, you just plot this, you will get one axis here. It will not give you the names. You will get one axis, you'll get the line, and that is it, right? But these are the advantages of using it. It makes the plot also look a little bit nicer, right? So yeah, so that's the line plot. If you want to change the mean to something else, let's say you want to change it to median, right? That's why I imported from NumPy, import median here, right? You can use the median. You can use an argument called estimator and give that function, which is the median, right? So now this line will now show the median instead of the mean when I run this code, right? And you can also change this shaded area around it from the confidence interval to, let's say, standard deviation. So you want to show the mean and the standard deviation, you can do that, right? Okay, let me run this. Now this is the median, right? And this is the standard deviation, right? So you see the number has changed. Here it's 2.8, here it's around 2.5, right? And this area has also changed. It's 2.4 to 3. Here it is larger, right? It's 1 to 3.5, right? So now the same line plot, I'm going to make a few more changes, right? I'm going to add one more variable to it, right? And that is the column called smoker. Is that person a smoker or not, right? So if he's a smoker, they'll have a different line. If he's not, they'll have a different line, right? And so that goes into this argument called style, right? And I have enabled the markers to show, where the points are. Each and every point will have a marker now, right? So yeah, so smoker has a round marker and non-smokers have a X marker, right? With a dashed line. So by default, so once you say the markers, style variable is included, by default, what Seaborn does is it changes the line style as well as, it changes the line style mainly, right? That's why it comes under this argument called style, right? And since you enable the markers, it will show different markers as well, right? So if you, let's say this shaded area is now disturbing, at least here it was good, right? But now it's disturbing me because you have to, you have two areas overlapping, right? So if you want that removed, right, you can use this ci is equal to none argument. So earlier you used ci is equal to st, and ci by default is the confidence interval, right? Now if you make none, that will go away, right? And let's say you don't want these two different style of lines, but you still want two lines, right? Not the different styles. You want both to be solid lines, right? So you can do that using dash is equal to false, right? You make that and you get this one here and with the X marker here, right? Now let's say you want, a very distinct color for those two lines, right? So you add your old, palette, and I also wanted to see one line for each different gender, right? So basically 4 lines, right? I'm going to give gender on color and style on smoker, right? So the markers will indicate if that line is a smoker related line or not, and the color will indicate if it is a male or a female line, right? So let me run this. That's what you have, right? I have removed the dash is equal to false, so that some distinction is visible, right? So you have dotted lines for non-smokers and solid lines for smokers, right? And the color gives you the gender, right? Okay, so these are two very, very basic plots, right? One is line plot and one is scatter plot. Okay, so to visualize relationship between variables, now I'm going to show you something called relational plots. Okay, it's called a rel plot. What it does is it can build you subplots inside the main plot. I'm just going to use these two types, right? One of these two types, I'm using scatter. Right? So what I've done is I wanted to make this, same plot, which is the total bill and tip, right? By size, which is this plot. If you remember this, right? This plot, I want to do it, but I want to do it separately for different genders, right? So what I've done is I've added one thing. So basically I changed this to rel plot, right? This all stays the same, right? I've added kind equal to scatter. Now because so there are like different types of rel plots. So you can make a line plot, you can make a scatter plot, right? So what you want to specify inside it. So this is a new parameter, it's called kind equal to scatter, right? And I've added columns equal to sex. So for every sex, there'll be one column, right? So there'll be two plots, one on the left and one on the right. Okay, so I'm gonna run this. Here you go. Now this is two subplots inside one single plot, right? And it is split in the columns by sex, and you have everything else, whatever you wanted to build, right? So just adding a bit more, right? Now I'm adding both a column and a row, right? So a column for each label in the sex and row for each label in smoker, right? So if I do this, you get this, right? There's a combination of each and every variable on each and every subplot, and you get the same data visualized, which is total bill versus tip, right? Now that's an introduction to relational plots. Okay, so Yeah, before I move on to the next one, any questions up until now?
Sina, can you move on to the line charts we had?
Yeah.
A little more. You said CI is equal to none. Does it like removes that highlighted part we have around
Yes.
each line?
Yes. Yeah.
Okay.
So here it is CI none, and you don't have that highlighted area.
And we have to mention that every time because
Yes, by default it'll build it. Yeah, by default it'll be like this. Yep.
Okay. Yeah.
All right. Okay. Now proceeding to other kinds of plots. Okay. So I'm going to show you something called a count plot. All right. It's more like a histogram, right? But individual bars, right? A count plot for every X, categorical label, you'll have how many Y labels there, right? Sorry, I didn't load the data set. Now I'm loading iris, a very commonly used, learning data set, right? You have sepal length, width, petal length, width, and species. Right? That's what you have. So for each and every different species, you have lots of different flowers that are taken, and the observations are there in every row. Right now, I'm just going to use that data set, which is df2. I have stored it under df2. Right? Data is equal to df2 and x is equal to species, which is this column, right? And I just used count plot. Right? So it'll basically count how many different types of labels are there inside this column, and it'll give you the count. It's all 50, 50, 50, right? And 3 different species. That's an example of a count plot. Now there's something called a box plot, right? That you guys know as well. So I'm building in x-axis species, in y-axis sepal width, right? But I want to see the distribution of sepal width, right? For every species. What is the minimum? What is the maximum? What are different quantiles, right? What's the median? Stuff like that. And what are the outliers, right? This will give me that. So it's basically a SNS.box plot with X and a Y. So it makes a job a lot easier, right? With just X and Y and specifying that the plot type, you get what you want. These are outliers. Now, if you want to change this order, the X order, you can do that, right? By giving the labels explicitly in what order you want them. Right now it has changed from Setosa, versicolor, and Virginica to Virginica, versicolor, and Setosa because I mentioned it in that order. Right. Now this whiskers are there, right? These whiskers, you can change them. So by default, it runs, to 1.5 times the interquartile range. Okay, that IQR it's called. IQR is basic. So now this midline is a median, 50 percentile. This is 25 percentile. This is 75 percentile. Right now, the difference between the 25 and 75 is the IQR, right? And this whiskers run up to 1.5 times the IQR, right? So that's the default amount. Outside that 1.5 times IQR, they're considered to be outliers. Now, if you want to change that, you can do that. So by using this argument called whis and changing it to 1, now it'll run for 1 times the IQR, right? So if I run this, so here you have 1 above and below, 1 above and below, you have 2 1, right? Because the IQR reduced, so outliers increased, right? There's also another way to change the whiskers by explicitly giving the percentile you want them to start from and end at, right? Now if you want to cover the whole range, don't show outliers, just show me the min and max for the whiskers, right? So 0 percentile to start with and 100 percentile to end with, right? You pass that as a list to the whis argument and you get this. No outliers, it runs from the minimum to maximum, right? Yeah, so that is some basic functional customizations in terms of the readability of charts for box plots, right? Now there's something called cat plots, very similar to rel plots there, where so relational plots are like these kind of plots for understanding the relationship between 2 quantitative variables. Okay, that's why you have charts like scatter plots, line plots there, right? But when it comes to categorical plot, it is 1 categorical variable versus 1 quantitative variable, right? So cat plot is very similar to rel plot, but the chart types are different. That's all. So here also you can build multiple subplots inside a single plot, right? So I have done day on the X and tip on Y, right? And column is smoker and row is sex and kind is box. So basically I'm making a box plot. Here the kind is box, if you remember, right? I mean, that's the main thing to do. Check here. So you can build a point plot or a box plot or any kind of a categorical plot. If you want to put that into subplots, you can use cat plot function, right? And yeah, so if I run this, I will get box plots. In columns you have smoker, yes, no. In row you have male, female, right? That's something that you can do, right? And finally, I just wanted to show you two different types of plots. Then we'll stop there, right? One is called a strip plot, right? It basically gives you this kind of a visualization. The same thing, the distribution, right? Here also it's a distribution, the box plot. Here also it's a distribution, right? But it's slightly differently represented, right? So it is not a single box anymore. It is stripped down to individual points, and you can see all those points there on the respective y coordinates, right? The more denser it is, the more points you'll have on that line. Okay. Yeah, that is one visualization. Another one interesting thing is this violin plot. This also shows you the same distribution of that quantity variable on this categorical variable, but it shows you far more detail, right? It gives you the density, right, by y. That is it takes the same amount of space as this, right? But it gives you more information in terms of distribution. It doesn't give you information in terms of this quantiles that you want to know, right? So that's another representation, right? Yeah, so basically this function is called violin plot and this function is called strip plot. You can just call those and give the x and y, and you'll get those. That's what I had for today.